Hello students, welcome to the 11th video of straight lines. In this video, we will derive the formulas for all these three. Length of perpendicular from a point to a straight line. We'll derive the formula, we'll do few problems. We'll also derive the formula between distance between two parallel lines. We'll derive the formula to find distance between parallel lines. We'll do few problems. We'll also derive the formula to find the area of parallelogram when equation of four sides are given. Okay, and we'll do problems based on this. So let's get started. Okay, first, length of perpendicular from a point px comma y1 x1 comma y1 to a line ax plus by plus c is equal to 0 is modulus of ax1 plus by1 plus c divided by root of a square plus b square. We will derive this formula now. Okay. Let us say we have x-axis and y-axis. Alright. And let us say this is the equation of this line. Ax plus by plus c is equal to 0. Okay. This line is ax plus by plus c is equal to 0. Okay. Alright. So let us say we have point P here and it is x1 comma y1. Point can be anywhere. It can be here, it can be here, it can be here. Okay, anywhere. We took the point here. Now we will find this distance. This will be the perpendicular distance, right? Okay. What is the shortest distance of this point? Suppose if you want to, from here, if you want to reach this straight line, what would be the shortest distance? Perpendicular distance would be the shortest distance, right? Okay. So when we talk about the distance between point and a straight line, we generally talk about perpendicular distance. Okay. So let that perpendicular distance be, let us say P. Okay. This is the point P x1 y1. This is length. Okay. And this equation is ax plus by plus c is equal to 0. Alright. Okay. See. Understand the concept. The length of perpendicular from this point to this line is given by this formula. Okay, all you have to do is substitute x1 y1 in this. x1 y1, see ax1 plus by1 plus c divided by coefficient of x whole square plus coefficient of y square under root. Okay, let us derive that formula. Now, see, what we'll do now here is we will find this points. Let us say this is point A, okay, and this is point B. How should we find this point? This is x-intercept, this is y-intercept, right? Okay, so we know how to find that. Ax plus by equal to minus c. This c goes on the other side. Let us divide both sides by minus c, because in intercept form here we need 1 always. So this will be equal to x by minus c by a. This a goes to the denominator plus y divided by minus c divided by b. Okay. So this point is minus c divided by a comma 0 and this point is 0 comma minus c divided by b. Okay. We are talking about the intercepts. Don't worry whether, see, if you plot a point here and point here, this would be positive, right, and this would be positive, but don't worry about the signs as of now. Okay. Okay. Now let us find, see, let us join these 2 points P with B and P with A. Alright. So here what we'll do is we'll find the area of this triangle. Let me just write this as some M, because P and B will get confused, right? Okay, we'll find the area of this MAB. Okay, so area of triangle MAB will be equal to half into, we have studied how to find the area of triangle, half into base into height. Okay, now half into, what is base? See, if you take this as base, this will be the height, right? AB, length of AB is base and height is the perpendicular distance. Okay, half into base. Base is what? AB multiplied by height. Height is the perpendicular distance P. Okay, this is area of triangle. Now, in the 10th standard, we have also studied that when 3 points are given, 1, 2 and 3, 3 points are given, we know how to find the area of a triangle, right? Okay, using this formula, area of triangle, when 3 points are given, y minus y plus x, y minus y plus x, y minus y, right? 1, 2, 3, 2, 3, 1, 3, 1, 2, using this formula. So we have 3 points here. If you take this as x1, y1, this as x2, y2, x2, y2, this as x3, y3, and substitute this here, that area should be equal to this, isn't it? Because both are triangles MAB only, right? So we'll substitute these values in this and we'll equate this two. Okay, all right. So half x1, what is x1? It is x1 only, right? x1 y2 minus c by b minus y3 is how much? 0 plus x2. x2 is 0. So you write anything here, it will become 0 only, right? Plus x3. x3 is minus c by a. y1 is y1 minus y2. Minus of minus c by b. Okay, mod. Alright. So this will be equal to half. Let us multiply this. Minus c x1 by b plus this is 0. Okay, minus c y1 by a minus c square by ab. We have multiplied c by a with y1 and with c by b. Okay. So we have this. Now, see, we need to equate this part and this part because this is area of MAB. This is also area of MAB, right? So let me just rub this part. Rub some part from here. Okay. I'll rub this also. Let us equate. Okay. Okay, we need to find AB first. Let us find AB using this x2 minus x1 whole square plus y2 minus y1 whole square formula, right? Distance between the 2 points formula. Okay. So what will be this? If you take this as x1, y1, 0 minus of minus c by a whole square plus minus c by b minus 0 whole square. Okay. This will be c by a whole square, that is c square divided by a square plus c square divided by b square, right? So this we can write it as, can we take c square common? Yes, if you take c square common, 1 by a square plus 1 by b square will come here, right? Okay, so this will be equal to c root, see, a square b square LCM, here b square plus a square will come. Okay. Alright, and you can remove this and write it as c root of a square plus b square divided by ab. Okay, alright, this is the length of ab. So let us equate half. ab is how much? C multiplied by a square b square divided by ab multiplied by perpendicular distance should be equal to this part. Half modulus of, see, this is modulus, right? If you take minus, everything you can write it as plus, right? Let us remove this now. Okay, it will be like this. Half, I hope you understood that step. And let us take c common, it will be x1 by b plus y1 by a plus you are taking 1c common, right? So c by ab will come here. Okay, so this will be c by 2. So c and 1 by 2 and 1 by 2 will get cancelled, right? So let me just rub. We got the formula now. Okay, now see here, this is a square b square under root divided by ab multiplied by p. We need to find this p, right? Okay, now if you simplify this, what would this be now? See, multiply both sides by ab, or see, you can send this ab on the other side, right? You can do that. We have like this, right? C by ab. If you send this ab, which is in the denominator, on the other side, it will be multiplied with every term, right? It will be like this. AB and C divided by AB will come here. And this is P multiplied by root A square plus B square. So BB cancel, AA cancel, AB cancel. What do we have? We have AX1 plus BY1 plus C. And this root goes on the other side, becomes denominator, right? So since this is the distance, it cannot be negative, right? So we write modulus here. Hence this is the perpendicular distance of a point on a straight line. Okay, I hope this is clear. This is the derivation. Okay, now let us derive this formula. Distance between parallel lines ax plus by plus c1 is equal to 0 and ax plus by plus c2 is equal to 0. These two are parallel lines. Okay, see, only the constant will be different. Okay, and what is the distance between these two parallel lines? Modulus of c1 minus c2 divided by root a square plus b square. We can write modulus of c2 minus c1 also. It will make no difference. Okay, so let us see the derivation now. We have a diagram here. This is our x-axis and this is our y-axis. Okay, origin 0, 0. We took this line as the first line, ax plus by plus c1 is equal to 0, and this line as ax plus by plus c2 is equal to 0. You can take this line as the second line or this line as the first line. It will make no difference. That's why c1 minus c2 or c2 minus c1. Okay, now see, what we'll do is, we'll find the distance of this origin from this straight line. Okay, just few minutes ago we have derived one formula, right? Distance of a point from a straight line. Okay, we'll find that, and we'll also find the distance of origin from the first line, and from the second line. Okay, let this be C, let this distance from here to here be P1. Okay, and let this distance be P2. Now we need to find this distance between parallel lines. Okay, this is one parallel line and this is another parallel line. So we need to find this part, distance between the two parallel lines. It will be equal to how much? P1 minus P2. P1 minus P2 will be the distance between the two parallel lines. Okay, alright, let us find P1 first. Okay, see, we just now saw the formula ax1 by1 plus c divided by root of a square plus b square. Okay, see, if we have a straight line and if it is ax plus by plus c is equal to 0, and if we have a point x1 y1, the distance between this point and the straight line, that is perpendicular distance, will be given by this formula, right? Okay, now the point here is 0, 0. Okay, point here is 0, 0. And what is the first equation? It is ax plus by plus c1 is equal to 0. So let us substitute these values in this formula. So it will be equal to a into 0 because x1 is 0, plus b into 0 because y1 is 0, plus c1 divided by root of a square plus b square. This is P1, right? This is P1. Can we find P2 now? Yes. Origin is same, right? 0, 0. Only, see, now the line is this line. The line is ax plus by plus c2 is equal to 0. Let us substitute these values in this formula. We'll get P2. So P2 will be equal to a into 0 because x1 is 0, right? b into 0 plus c2 divided by root of a square plus b square. This is p2 now. Okay. Now what is p1? p1 is c1 divided by root a square plus b square inside the modulus, right? What is p2? p2 is c2 divided by root a square plus b square. Okay. Now we need to find p1 minus p2. We need to find this distance. Okay. This total is p1, this is p2. So p1 minus p2 will give us distance between the parallel lines, right? So p1 minus p2. So what is p1 minus p2? p1 is how much? c1 divided by root of a square plus b square minus p2 is c2 divided by a square plus b square. So this you can write it as c1 minus c2. Denominators are same, right? We can write it once like this. Since it is distance between parallel lines, we write this in modulus. You write whole modulus like this. Okay. It will make no difference. Alright. C2 minus C1 will also give you the same result. C1 minus C2 will also give you the same result. Okay. So this was the derivation of distance between two parallel lines. We'll do few problems now. Okay. We have a problem here. Find perpendicular distance from the point minus 3, 4 to this straight line. Okay. Just now we have derived these two formulas. Perpendicular distance formula, distance between parallel lines. We will apply this formula, right? Okay. See, let us draw a rough diagram. This is the straight line. 5x minus 12y minus 2 is equal to 0. I am writing this plus 2 on LHS. Now, there is a point minus 3, 4. We need to find the distance of this point from this straight line, which means we need to find the perpendicular distance only, right? Okay. Let us apply this formula. Ax1. A is how much? 5. So 5 in place of x1 minus 3 minus 12 into y1. Okay. Minus 2. This is inside the mod divided by root of a square plus b square. A square is 5 square plus b square is minus 12 square, right? So this is minus 15 minus 48 minus 2 divided by 5 square is 25, 12 square is 144, right? Okay, so here 48 and 2, 50, 50 and 15, 65, minus 65, but if you remove the mod it will be plus 65, right? We take distance as positive. And this is 25 and 144, 169. So 65 divided by root of 169 is 13. Okay. Will it go 5 times? Yes. 13 5 is 65. So the distance is how much? 5 units. Okay. Okay, we have a problem here now. Find distance between parallel lines 3x plus 4y minus 3 is equal to 0 and 6x plus 8y minus 1 equal to 0. Okay. See, one common mistake students will make here is they'll directly apply this formula c1 minus c2 divided by root a square plus b square. It is distance between two straight lines formula, right? See, ax plus by plus c1, first line should be ax plus by plus c1, second line should also be ax plus by. Coefficient of x, coefficient of y should be same. Only the constant terms should change, right? But here, see, coefficient of x is 6, coefficient of x is 3 here. Coefficient of y is 8, coefficient of y is 4 here. Okay. We should make the coefficients same. How can we do that? Can we multiply this first equation by 2? Yes. If we multiply by 2 on both sides, this will become 6, this will become 8. We'll have 6 and 8 here. Okay. First see the coefficients of x and y are same or not. If they are not same, make them same. Okay. Alright. See here they are not same, so we are multiplying both sides by 2. So if you multiply both sides by 2, this will become 6x, this will become 8y minus 6 is equal to 0 into 2 is 0. So the lines are like this now. That is the first line and this is the second line. If you compare this with ax by plus c1 is equal to 0 and ax by plus c2 is equal to 0, c1 is minus 6, c2 is minus 1. Okay, substitute this in this formula and a is 6 and b is 8. So distance between two parallel lines is what? Modulus of c1 minus c2. c1 minus 1. So this will become plus 1 whole divided by root of a square plus b square. 6 square plus 8 square. Okay, I hope this is clear. So this will give us minus 5 in the numerator, but I am writing plus 5 because we have a modulus there, right? And distance cannot be negative. So 6 square is equal to how much? This is equal to 36 and 8 square is 64. Okay, so this is 5 divided by root of 100, 5 divided by 10 equal to 1 by 2. Okay. Okay, we have 3 questions here. Find length of perpendicular from the point against the straight line, against the given straight line. Okay, we have a point and we have a straight line. We need to find perpendicular distance. Apply this formula, right? I'll do the first problem. You please do second and third. Okay, it will be a good practice for you. So here x1 y1 is minus 2 minus 3 respectively, right? We need to substitute it there. So ax1. So this is a, what we have to do in place of x and y, we need to substitute this values, right? That's all. So 5 into minus 2 plus 2 into minus 3 plus 4 divided by root of 5 square, okay, plus minus 2 square. Okay, so this is minus 10 minus 6 plus 4 modulus divided by 25 plus 4. Okay, is it correct? 5 to the 10, 6, yes. Five into minus 2. Wait, I made some mistake. 5x minus 2y plus 4 equal to 0, minus 2 and minus 3. Yes, the question is correct. Okay, sorry. Here, you see, minus is there, right? I wrote plus. Okay, sorry about that. So this will become plus 6. So minus 10 plus 10 divided by root 29. So minus 10 plus 10 is 0. 0 by anything is equal to 0. Now the perpendicular distance is 0. How is it possible? See, if we had a straight line here, ax plus by plus c equal to 0, and if we had a point here x1 y1, this distance is p, right? But now we got that distance as 0, which means the point is lying on the straight line, right? The point is not here, the point is here on the straight line. Alright, see, let us check. Let us substitute minus 2 and minus 3 in this. 5 into minus 2. Just now we substituted that only, right? 5 into minus 2. Okay, which means this point is lying on the straight line and the distance between that point and the straight line is 0. Okay, you please go ahead and do the second and third bit. Okay. Find distance between the parallel lines. 2 questions are given. Okay, these 2 are parallel lines. We need to find the distance between these 2 parallel lines, and we need to find the distance between these 2 parallel lines. Okay, see, one common mistake I have observed students doing is, see, let us take the first one. This is the first equation, right? Suppose the second equation is like this. Let us say this is minus 7 is equal to 0. Okay, so they take this as C1, this as C2. They write C1 is equal to plus 12 and C2 is equal to minus 7. Okay, see, if you see the formula, distance between the parallel lines ax plus by plus C1, and here ax plus by plus c2. This c1 and c2 should be on LHS, right? Okay, all the terms should be on one side, but here what do we have? See, one term is here. So first write this like this. Okay, so this 12 goes on the other side, becomes minus 12. So this 7 goes on the other side, 3x minus 4y, it will become minus 7. Okay, write it in the standard form first. Alright, we need to find the distance between parallel lines, right? C1 minus C2. See, x term, x coefficient, y coefficients are same, right? So C1 minus C2. So this is minus 12 minus of minus 7. This is C1, this is C2. So this will become plus 7 divided by root of a square plus b square. That is 3 square is how much? 9. Minus 4 square is 16 plus 16, right? So this will become minus 5. This will become minus 5, right? Yes. So modulus means 5. In the denominator also see 25. Root 25 is equal to 5. So the distance is equal to 1. Distance between these two parallel lines is equal to 1. Okay. What about this one? See, the coefficients of x and y's are different. So let us multiply this equation by 2 on both sides. So this will become 10x minus 6y minus 8 is equal to 0 into 2 is 0. Okay. So we have two equations now in the standard form. Okay, let us find the distance. C1 minus C2. So minus 8 minus of minus 9. So this will become plus 9 divided by root of 10 square. Okay, plus minus 6 square. So this is 1 in the numerator divided by 136. So this is 136. Okay, I hope this is clear. 1 by root 136. Okay, if four straight lines are given, ax plus by plus c, ax plus by plus p is equal to 0, ax plus by plus q is equal to 0, and cx plus dy plus r is equal to 0, cx plus dy plus r is equal to 0. Okay, and they form a parallelogram. The area formed is this. Okay, see, in some books this is given as a1x plus b1y plus c equal to 0, c1 is equal to 0, a1x plus b1y plus c2 is equal to 0, right? Okay, it will make no difference. We are just changing the standard forms, right? We are writing these lines in terms of a, b and p, q, r and s. Okay, now see, clearly these two lines are parallel to each other, ax plus by, ax plus by. Only the constant term is changed, right? Alright, and these two lines are parallel to each other. Let us draw the diagram. Okay, let us say this is our parallelogram. Yes, okay. This is our parallelogram. Let us say this is the equation of first line, ax plus by plus p is equal to 0, and ax plus by plus q is equal to 0. Okay, and this is cx plus dy plus r is equal to 0, and this is cx plus dy plus s is equal to 0. Let us name this parallelogram A, B, C and D. Okay, see, these two lines are parallel to each other, these two lines are parallel to each other. We need to find the area of this parallelogram, and we need to prove that area of this parallelogram is this: P minus Q multiplied by R minus S, denominator BC minus AD divided by BC minus AD. It should be in mod, okay, because area cannot be negative. How should we prove this? See, we have studied in the lower classes that area of a parallelogram, what is the formula? Area of parallelogram is equal to, it is same as rectangle's area, right? Base multiplied by height. Okay, alright, see, base is AB here. If you take AB as base, height will be this, distance between parallel lines. Okay, distance between parallel lines will be the height. Okay, so base is what? AB multiplied by distance between parallel lines. Okay, Few minutes ago we have studied the formula C1 minus C2 divided by root A square plus B square is the distance between parallel lines. So here C1, C2 is what? P and Q. Okay. So in place of C1 and C2, let us write P minus Q inside the mod divided by A square plus B square inside the root. So this height is how much? P minus Q divided by root A square plus B square. Okay. I hope this is clear. Okay. Or you can take this as P1. Alright. So P1 is how much? This part, P minus Q divided by root A square plus B square. Okay. Alright. Now, how should we find the base? Okay, how should we find the base? If we can find the base, we can substitute it here, right? And find the area of parallelogram. Okay. Now see, to find base, let us do one thing. Let us drop a perpendicular from this point, okay, on this line. This is, see, if this is base, this will be the distance between the parallel lines, right? These two are parallel lines. This line will be this much distance will be the distance between the parallel lines. Let it be P2. Okay. And if we take angle between the lines as theta here, this angle will also be equal to theta, because in parallelogram opposite angles will be equal. Okay. If we consider this as theta, this will also be theta. Now see, instead of finding AB, we'll find CD, because CD and AB will be equal. Opposite sides will be equal in parallelogram, right? So we'll find CD and we'll substitute that value here in place of AB. Okay. Alright, let us find this. See, this will be a right angle triangle since it is a perpendicular, right? Okay. So if you consider only this right angle triangle, let me just draw that right angle triangle here again. It is like this. This is 90 degrees. This is theta and this is DC, and let us say this is some M. So this is M. Okay. So and this is P2. Can we find DC now? Yes, using sine, right? What is sine formula? Opposite divided by hypotenuse. So this is opposite. DC will be hypotenuse, because 90 degrees is here. Opposite to 90 will be hypotenuse, right? So sine theta will be P2 divided by DC. Okay. Alright. Okay, so sin theta is P2 divided by DC, or can we write DC as P2 divided by sin theta? Yes, but see, this DC is same as AB, right? So in place of AB, let us write DC, okay, in place of AB we can write DC, and DC is again equal to how much? P2 divided by sin theta, and this was P1, right? This whole thing was P1. So you can write the area of a parallelogram like this: distances between the parallel sides divided by sin theta. Alright? Okay. So, oops, I deleted this, right? This was what? P minus Q modulus root of A square plus B square. Okay. P minus Q divided by A square plus B square. Okay. Now, see, what is the value of P2 now? P2 is the distance between these two parallel lines, right? So if we apply C1 minus C2 divided by root A square plus B square concept, okay, formula, this will be R minus S. This is the distance, right? R minus S divided by root of C square plus D square. C square, coefficient of X square, coefficient of Y square, right? Okay, so this P2 is how much? R minus S divided by root of C square plus D square, and we have this P minus Q divided by root A square plus B square. Okay. There is sine also here, so we'll write 1 by sine here. Okay. Now, how should we find the value of sine? Okay, how should we find the value of sine? See, theta is the angle between the two straight lines, isn't it? If you consider only these two straight lines, DC and CB, theta is the angle. You can consider this angle also. Okay, let us take this only, it will be easier. See, theta is the angle between the two straight lines, and we have studied angle between two straight lines formula is what? A1 A2 plus B1 B2 divided by root of A1 square plus B1 square multiplied by root of A2 square plus B2 square. In one of our previous videos, I think in the 9th video we have studied this. Okay, 9th or the 10th video. Okay, so if you did not watch that video, I highly recommend you please go watch that video. Okay, so this is how we should find the value of cos theta, right? So but here A1 A2 is what? It is A1 is A, A2 is C, B1 is B, B2 is D. Okay, we'll substitute that. Okay, alright. So cos theta will be equal to, this two should be multiplied, A1 A2 plus B1 B2, that is BD, divided by this two, root of A square plus B square multiplied by root of C square plus D square. Okay, if we know cos theta, we can find sin theta also, right? Okay, using this formula. See, we know sin square plus cos square is equal to 1. If you send cos on the other side, 1 minus cos square will come here, right? So we can find sin value. So sin square will be equal to how much? 1 minus cos square theta. So if you square this, okay, this is cos square theta, right? So 1 minus AC plus BD divided by root of A square plus B square multiplied by root of C square plus D square whole square. Okay, alright, so this square goes on the other side, becomes root. So let us find this now. 1 minus, so this will be AC plus BD whole square divided by, see, this will become A square B square multiplied by C square D square. Okay, alright. Now if you find the LCM, it will be A square B square multiplied by C square D square, and 1 into this part, A square B square multiplied by C square D square minus AC plus BD whole square will come here, right? Okay, this is different, right? Okay, now if you multiply this A square, see, A square C square plus A square D square plus B square C square plus B square D square minus expansion of this. Okay, A square C square, see we have a minus sign also here, minus B square D square minus 2ACBD divided by A square B square multiplied by C square D square. Okay, so here A square C square, A square C square will get cancelled, right? Here square will come, B square D square, B square D square will get cancelled. So let me rub this part, because I don't have place here to write one more line. Okay, okay, now what do we have? See, can we write this as AD plus BC whole square or BC plus AD whole square? Yes, see, minus BC minus AD whole square, the numerator. If you expand this, you will get this part only, divided by, we have A square plus B square multiplied by C square plus D square. This is sin square theta. So if you want to find sin theta, this square goes on the other side, becomes root, right? Okay, so let me rub this part. So this is the value of sin, right? What is the value of sin? See, squares, if you remove, this is BC minus AD divided by root of A square plus B square, okay, multiplied by root of c square plus d square. This is the value of sine. Let us substitute this here. It is 1 by sine. Okay. So in place of this sine, I am substituting this value. So this will be BC minus AD divided by a square plus b square inside the root multiplied by c square plus d square inside the root. So what will happen? See, these terms will get cancelled, right? So what do we have now? We have r minus s multiplied by p minus q inside the mod, because we have modulus here, divided by bc minus ad. This should also be in modulus, okay? Alright, because the area cannot be negative. So we have, see, same thing, r minus s, p minus q. R minus s, p minus q divided by bc minus ad. Okay, I hope this is clear. In some books, these equations will be given in a different form. Okay, they'll write this as a1x plus b1y plus c1 equal to 0. Okay, and a1x plus b1y plus c2 is equal to 0. Okay, and here a2x, I hope this is visible, a2x plus b2y plus, let us say, c3 is equal to 0, and a2x plus b2y plus c4 is equal to 0. Okay, in that case, this p minus q, r minus s will become what? c2 minus c1, okay, or c1 minus c2, and this will become c3 minus c4. Alright, so see, this will change to c1 minus c2 multiplied by c3 minus c4, okay, and here this will be bc. See, it is modulus of this, a1, a2, b1, b2 will come here, okay, determinant. Alright, so this will be a1, b2 minus b1, a2. Okay, you write the formula in this form or this form, it is one and the same. Alright, I hope you understood the derivation. Okay, let us solve this problem. This will be the last problem in this video. Find area of parallelogram whose sides are given like this. Just now we have derived a formula. If we have 4 lines, okay, and if these 4 lines will form 4 sides of a parallelogram, the area is given by this p minus q multiplied by r minus s divided by bc minus ad. Okay, alright, see here, these 2 lines are parallel to each other and these 2 lines are parallel to each other. Okay, so let us compare this with that one. So this 3x plus 4y plus 5 is equal to 0. We can write it as ax plus by plus p is equal to 0. And this is see, 3x plus 4y minus 2 is equal to 0. You can take this as ax plus by plus q is equal to 0, right? And this one, cx plus dy plus r is equal to 0, and this cx plus dy plus s is equal to 0. Okay, let us substitute this p minus q. P is how much? 5. So 5 minus q. Q is minus 2. So minus of minus 2 will become plus 2. R minus s. R is 1 minus s is how much? Minus s. Minus 7. So minus of minus plus 7 divided by BC. Okay. What is B here? B is 4. C is 2. So 4 2s are 8 minus AD. A is 3 and D is also 3. 8 minus 9. So everything should be in mod, right? So 5 plus 2 is how much? 7, and this is 8 divided by minus 1. So this will become 7 into 8 by 1, right? If you remove the mod. So this will be equal to 56. So 56 square units is the area of a parallelogram formed by those 4 straight lines.